All right, here's three harder ones for my honors kids. One of them said place 80 grams of oxygen in this cup, and you had water. 80 grams of just oxygen in the cup. Well, let's see. A mole of water weighs 18 grams. And if you put 18 grams of water in a cup, you would have 16 grams of oxygen. Don't you agree with that? So oxygen is really 16 grams per mole in water. So if you wanted to put 80 grams of oxygen in this cup, you'd say, well, there's 16 grams per mole, right? We need 80 grams of oxygen. 80 grams divided by 16 grams, or better yet, 80 grams over 1 times 1 over 16 grams, because this is just the oxygen, equals how many moles? 80 divided by 16 equals 5. So you'd need 5 moles of water. All right, water weighs 18 grams per mole. 5 times 18. If you put 90 grams of water in the cup, you would have 80 grams of oxygen in the cup. There's many, many ways to solve this. I just chose one. Here's another one. Place 14 grams of chlorine on this scale, and what you had was table salt. All right? 14 grams of chlorine on this scale. All right. In table salt, if you had 1 mole, you'd have 35.5 grams of chlorine. Does that make sense? If you only want to put 14 grams of chlorine on the scale, you don't need a whole mole. 14 grams is the number given times 1 over the proper number. Grams per mole is chlorine. So 14 divided by 35.5 equals 0.39. So if you have 0.39 moles of salt, you'll have 14 grams of only chlorine. Now, 0.39, okay. How much does a mole of salt weigh? It's 23 plus 35.5, so 58.5 grams is 1 mole. And if you only put 0.39 moles on the scale, if you put 23 grams on that scale, 14 of them would be chlorine. Last one I'm going to help you with. The last one I'm going to help you with. You have sodium phosphate, and you need to only put 2.7 times 10 to the 23rd atoms of sodium on this scale. 2.7 times 10 to the 23rd atoms of sodium on the scale. All right, there's many, many ways to do this. Many ways to do this. Sodium phosphate has 3 atoms per every compound, correct? So you would only need to have 1/3 of this many compounds, right? To have 2.7 times 10 to the 23rd atoms. So let's find out what 1/3 of this number is. 2.7 EE23 divided by 3 equals 9 times 10 to the 22nd. So if you have 9 times 10 to the 22nd compounds of Na3PO4, then you would have this many atoms. So let's figure out how much this weighs. 9 times 10 to the 22nd over 1 times 1 over proper number for a mole, 6.02 times 10 to the 23rd times the molar mass of sodium phosphate. We know from class that's 164 grams for every mole. 98 divided by 6.02 EE23 times 164 equals. If you put only 24.5 grams of sodium phosphate on the scale, you would have 2.7 times 10 to the 23rd atoms of sodium in that group of powder. Good luck, kids.